other. But imagine if we had a mechanism to generate namespaces outside the current workspace and a nice notation to deal with that. And this is something I've modeled in APL to begin with, so we can play with it a bit. So I have a function here called v13. I don't think we will ever have one of those. This is not the APL interpreter doing this, right? It's a model written in APL. So in Dyalog APL, you can say, give me 2 empty namespaces, and then in each one of those, create a matrix which is invertible. Probably invertible. Okay. Just have task manager here. We can see the fish tank. And then, okay, so if you say nss.rowmat, that says 500, 500, 500, 500, because there's 2 namespaces. Each one of them has a mat in it. And the dot just says, well, run that in both namespaces. And if I say something silly like, first try. Yeah, so multiply the matrix by its own inverse and display the upper left. Okay, now watch the fish tank. So my machine goes to 50% because it's a dual core machine like most people have these days. And it runs for about 18 seconds, I think. Anybody have a good joke? An 18-second joke? 17.6 seconds. Okay, and it did the deal. So imagine we had a system where we had a new primitive called fork, which you could give an argument of 2, for example. Say, give me 2 empty namespaces. And at the moment, what happened there was I started 2 runtime interpreters, right? That took about a second. And each one of those is now actually running what will appear to me to be a namespace. So I can go up here and I can say, okay, remote.mat gets that. Okay, so that set mat in those remote namespaces. And I can say remote shape mat. Yeah. And then I can go up here. And so here, this is it with a drum roll. Watch the fish tank. 100%. So our goal for version 12.1 is to fill the fish tank. 10 seconds. So, yeah, don't know what delayed it there. Usually it's very close to half the time. Okay, and if I say, so the way this works is, if I do that again, well, let's just do this one. There's a little parser here which detects that the thing on the left is one of these remote namespace thingies, and then it translates this in dot is a user-defined operator. It translates that into a defun because that's something I can encapsulate and send over a TCP socket. And then it executes it using Conga. And you see the overhead, I mean, this doesn't take, there's no delay here. And you would only want to use this for farming off something that took a serious amount of time anyway. Alexei. What do you mean, step on each other? Yeah. Well, no, that's, I mean, you can't control that. You've got a number of cores in the machine and they get shared. Yeah. I mean, using multi-cores, especially if you've got several applications, you've got dual core, you've got 2 applications that both say, well, I'm going to run multi-core, I'm going to use 2 cores. They don't both speed up 100%. And there's no way to achieve that. Maybe I should, I can't remember what's on the last slide. So when I then erase these, the APL tasks go away. Let me just finish, and then we can take some questions, because I'm over time. So the arguments to fork could be, create some empty namespaces, a list of reference to instances or namespaces. You then get those encapsulated outside the workspace. A workspace name, create a remote thing from a saved workspace. And the APL models almost all the performance benefits, but not the elegance of integration with the interpreter, which would really put parallel execution, I think, at the fingertips of an APL user. An APL user would be able to learn to type expressions like that and harness multi-core without learning heavy machinery again. But we want to wait a bit with actually putting this into the language. We'd like to, with some of the users who really have a need for this, experiment with the APL model and then maybe put it into the language